Okay, this is going to be a very quick video on expressions relating to the roots of a polynomial. So if you've already seen several results finding the values of expressions relating to the roots of a polynomial. So there's a couple of things about reciprocals which are quite useful for quadratic. 1 over alpha plus 1 over beta is just equal to a common denominator. You get alpha plus beta over alpha beta. You can see that extends to cubics and quartics as well. So we'll just look at the quartic one here. The bottom line of the quartic one, when you add all the reciprocals, is alpha, beta, gamma, delta, and then it's the sum of the triples, the product, all the different products of the triples here on the top line. So that easy to work with. Another couple of things which are useful here. Alpha squared plus beta squared is equal to alpha plus beta all squared and minus 2 alpha beta. In the same sort of way, you've got your alpha cubed plus beta cubed is equal to alpha plus beta cubed minus 3 alpha beta upon alpha plus beta. So it's nearly worth your while learning those wee results, those wee identities, as will come in useful. Okay, we're going to look now at an example here and see what we can do here for this one. Okay, part A just says quite simply to expand alpha plus beta plus gamma. So part A is going to say alpha plus beta plus gamma all squared is just equal to alpha plus beta plus gamma upon alpha plus beta plus gamma. Okay, I will write this out. I'll pause this and just write this out just to save a wee bit of time. Okay, so we just multiplied it out. You got alpha squared plus, then it's multiplied all the alphas, all these terms in the bracket by the alpha. So alpha squared plus alpha beta plus alpha gamma. Then multiplied all these terms by the beta. So I've just got beta times the alpha, beta squared, then beta gamma. Then I've multiplied all the terms in this bracket by the gamma. Gamma times alpha plus alpha times, that should be gamma times the beta plus the gamma squared. I'll just change that one now. That's should be my gamma times my beta. Okay, now notice you've got your alpha beta here, and then you've got a beta alpha, so that's 2 alpha beta terms. So that's why when you tidy this up, you've got 2 alpha betas. Likewise, you've got alpha gamma, and you've got your gamma alpha, so you have 2 alpha gamma terms, and also you've got your beta gamma and your gamma beta, so that's why you've got 2 beta gamma terms. So when you tidy this all up, you've got alpha squared plus beta squared plus gamma squared plus 2 upon alpha beta, alpha gamma, beta gamma. Done. Okay, part B says a cubic equation has roots alpha beta gamma such that then the pairs are equal to 7, and then just the sum of the roots are equal to minus 3. So it says find the value of alpha squared plus beta squared plus gamma squared. Why you'd want to do this, we don't know, but they do ask us. I always think of these questions that are very much just like a puzzle. So alpha squared plus beta squared, gamma squared, that's what we're looking for. And we know that from this identity over here, if you rearrange it, you would get alpha squared plus beta squared plus gamma squared equals brackets alpha plus beta plus gamma all squared minus this. So we're using what we've done in part A to do this. So it's going to be brackets alpha plus beta plus gamma all squared minus 2 times alpha beta plus alpha gamma, run out of space again, plus beta gamma. Okay, and then just fill in the values we know. We were told that alpha plus beta plus gamma is equal to minus 3, so that's brackets minus 3 squared minus 2 upon 7, which is just going to be 9 minus 14, which is just going to be minus 5. Okay, there's just a few useful identities here. So rules for the sum of quartics, sum of squares. For the quadratic, you've got alpha squared plus beta squared is equal to brackets alpha plus beta squared minus 2 alpha beta. The cubic one, which we mentioned earlier, I think, and the quartic one as well. So it's a wee bit more complicated. Probably worth your while to learn these. You can find similar results for the sum of the cubes of a cubic equation. You also hear the rules for the sums of cubes. So for quadratic, you've got alpha cubed plus beta cubed is equal to brackets alpha plus beta cubed minus 3 alpha beta bracket upon alpha plus beta. I think this is one we saw earlier. And then for the cubic, you've got this long one. I would never have learned this one, to be quite honest with you. I would just go work it out. So quite often in the question, like we had above here, it would be they would ask you to work something like this out, and then you would have to use that to answer the next part of the question. That's more likely the way they would ask you to do the thing. Okay, but you're now ready to exercise 4D, questions 1, 4, and 7.